Now, this one I made 1, 2, 3, 1, 2. I would need to make that a little longer to make sure that this is the same tension. And then I need both of these to have acceleration up, so greater force up, greater force up. So these two are both accelerating in the correct direction, and I've had these show that they are the same tension force. Now we write our F-net equation, so M1A is Fa minus tension minus the force of gravity. This one, M2A, is tension minus the force of gravity, M2G. Get tension by itself. Make sure to distribute that sign. Minus M1G equals M1A. We're trying to solve for the acceleration, so I have acceleration right here, but I also have it right here, so I need to get all my terms with acceleration over. Now I'm going to pull out the A. If you pull out the A, you're left with M1 plus M2. And this is your answer. Here, we're looking for the force needed to push at a constant velocity. Constant velocity tells me my forces are balanced. There is coefficient of friction. This is the force F, so let's draw our free body diagram. We've got our normal and gravity for sure. This guy feels that force F. Then they both have friction, so both friction forces will be pointing to the left. And then there's this force between the blocks, so I labeled it A and B and called this one FAB. You can call it really whatever you want because it's going to be like eliminated in the end. So the 2 pushes the 3M back, so FAB like this. And then the 3 pushes the 2 to the right, so FAB. Again, these are balanced, so I wouldn't necessarily write an F-net equation. I would say that these two are equal. So FAB is equal to the force of friction, which is mu Fn. Fn here is just your 2mg, so mu 2mg for the force of AB. Here I would say this force equals these two, so F equals the force of friction plus FAB. Force of friction here is mu Fn would be equal to Fg. The Fg of the 3m is 3mg. And now I just substitute in. This is mu 3mg plus mu 2mg, which is just 5 mu mg. And that's your answer, because I was looking for the force F. No acceleration because it's a constant velocity. Here we are accelerating horizontally. Friction is negligible, which means I can ignore it. Here I've got two masses. They each have a force of gravity. 3m obviously has a greater force of gravity, so it's like 3 times greater. And then they're on a surface, so the normal balances out the gravity force. This applied force F on that string is pulling, and then there is some tension between them. I'm going to call it T. So then I have T right here. That T is what's pulling the M, and I would need to make sure, so I made this 2, I would need to make sure this is also 2 to show that I know those are at the exact same force, same magnitude. Now we write our net force equation, so MA is just equal to T, 3MA is equal to F minus T. Substitute in, add this over, getting acceleration, so just divide the 4m over, and there's your answer. Now we're including friction, so I still have MA, but this would be minus friction, so T minus force of friction. 3MA is F minus T and minus the force of friction being mu Fn. Fn is just equal to your weight because it's on a surface, so that one would be 3mg, and this one would be mu just mg. Get T by itself. Once you have T by itself, we're going to substitute in. So this is 3MA equals F minus all of this. And then minus the force of friction, which was 3 mu mg. This 3 is just a coefficient. It doesn't matter if it's right here or out front because it's just getting multiplied by 3. Combine my terms, add this over. That's 4MA. Mu mg and 3mg, mu mg, these are the same. So this is like minus 1 minus 3, which is negative 4 mu mg. Divide the 4m over. This one I cannot cross off before the m. Now if it was just this, then sure, but see how I have this f right here? So I have f minus, I would need 4m in all of my terms, and I only have it in the second one, so I cannot simplify this. This is your answer. Number 3, I've got the 2 blocks. This one, it says right here, I'm going to assume that it counts for all of it. M2 is greater than M1, so I'm going to show this greater than M1. There's obviously some tension. This is the same string, so it's going to be the same tension. I need it to accelerate up, and this one to accelerate down. So I need it greater than this force of gravity, but less than this force of gravity. And then I'm going to label it, and I need to make sure to show that they are the same length, because it is the same force, same tension force. Now we write our F-net equations. So this one is T minus Fg, and this one is Fg minus T. Get T by itself. Substitute. Get your A's all together. This one's a 1. My bad. This was M1. M1G. And then now we pull out our A. Divide the M1 plus M2 over. And that's your acceleration. Last one, we have coefficient of friction, so include it. And we've got 2m right here, and oh no, m is on the table, 2m is hanging. Oh, that got cut off, but you can assume what's happening. Frictionless pulley, but the table is not frictionless. So I'm not losing any of my like energy right here, but I am right here. So free body diagram for the m would be tension and then some force of friction. Gravity normal, and then the 2m would just be the force of gravity and some tension. So it's still going to accelerate, right? When this is pulling, there's no way that the friction is going to be pulling enough to cause it to go to the left. It either doesn't move or it accelerates. It says determine the acceleration here. Let's assume that it accelerates, that it moves. Now I'm going to write my net force equation. So ma is equal to T minus force of friction. This one is 2ma equals force of gravity, which would be 2mg, minus the tension. Tension here would be ma plus the force of friction. When I add it over, the force of friction is mu Fn. Fn here is just the mg. That's mu mg. Minus, make sure you distribute that minus sign. Get the A's by itself, so this would be 3ma. Divide the 3m over. This is your answer. Here, see how I have dividing by m and I have an m in each term? So you can pull out that m out front, like this, and that can cross off, because I do have it in all my terms. So this is 2g minus mu g over 3. I can cross it off here, because it was in both terms.